this video is about seeing the scale factor of similar polygons and finding missing side lengths of similar polygons. So a similar polygon, remember, has all sides that are proportional. So for example, we would have DE is similar to AB, so we have DE over AB, which has to equal EF over BC, which has to equal DF over AC. So for example, if we gave side lengths to these and we said this is 5, 6, 7, 10, 12, 14, when I said all of those ratios, they would be equal to each other when they reduce, because all of these ratios reduce to 1/2. In similar polygons, all of our angles are also congruent. So corresponding angles are congruent. So D is congruent to A, E is congruent to angle B, F is congruent to C. In number 1, it says create a drawing that has bear similar to wolf, mark the congruent angles, set up the proportion ratios, and find the side lengths that would correspond to the scale factor. So we're going to draw two four-sided figures. One of them is going to be BEAR, and my other rectangle for my four-sided figure is going to be WOLF. So we need to know which angles are congruent. So remember that angles are congruent if they're in the same placement of their name. So B is congruent to W. E is congruent to O. A is congruent to L. And R is congruent to F. Then we also need to find our corresponding sides that are proportional to each other. So they would have the same placement in their name as well. So BE is similar to WO, so we're going to set up a proportion BE over WO, which would have to be equal to the next two sides, so EA over OL. Then we have AR, which is similar to LF. And then we have our last sides. BR must be similar to WF. Notice that when I did the similarities, they look like little waves instead of straight tick marks because we're using similarity, not congruence. Number 2, solve for x, find the scale factor and the similarity ratio, given that triangle JKL is similar to triangle MNO. So JK is the first two letters of the name. It is similar to the side MN. So we would have x plus 3 over 12. And then JL are the first and last letter, so they're similar to the side MO. So that would be the other part of our proportion. So we're going to set that equal to x plus 9 over 21. In order to solve for x, we need to cross multiply. So we have 12 times x plus 3 equals 12 times x plus 9. I'm sorry, 21 times x plus 3. So we get 21x plus 63 equals 12x plus 108. We can subtract 12x from both sides, so 9x plus 63 is equal to 108. We can subtract 63 on both sides, so 9x equals 45. When we divide, x is 5. So we're going to substitute 5 into the sides to find their length. So JK would be 8 and KL would be 14. So to find my similarity ratio, remember that scale factor, we're going to do scale factor first. So scale factor, remember, is our new over our old. So when we're given a statement, old is the first one, new is the second one. So we're going to pick a set of sides. I'm going to pick the 8 and the 12 side. So I would have 12 over 8, which reduces to 3 over 2. The similarity ratio then, remember, is old over new. So we could do 8 over 12, or remember it's just the reciprocal, so 2/3. Number 3, solve for x, y, and z. Find the scale factor and the similarity ratio. Find angle U, given that the triangles are similar. So first, I'm going to work on the angles. So if I look at angle P, P is the first letter of the triangle, so it corresponds with S. So P and S are congruent, so we know that angle S is 72 degrees. So to solve for x, we have 5x plus 7 equals 72. I'm going to subtract 72 from both sides. So 5x equals 65. Divide by 5, so x is 13. Then the other angle that has a measure is Q, and Q is the second letter, so it corresponds with angle T. So angle T is 68 degrees, so we can use that to solve for Z. So we have 6Z plus 14 equals 68. I can subtract 14 from both sides, so 6Z equals 54. Divide by 6, and Z is 9. The last angle we need to find is angle U. So remember in a triangle that your angles add up to 180 degrees. So we can do 180 minus 68 minus 72 and get that the third angle in the triangle is 40 degrees, which would also be angle R because they're the last letters of the name. Now we also need to find Y. So if I look at my sides, PQ has something written on the side, and PQ is the first two letters of the triangle name, so it corresponds with ST. So far in our proportion, we would have 4y minus 11 over 35. Then if I look at my triangle, the other side that has a number is PR. PR is the first and last letter, so it corresponds with SU, which also has a length. So we can set this equal then to 45 over 75 and cross multiply. So we get 75 times 4y minus 11 equals 35 times 45. So when I multiply, I get 300y minus 825 equals 1,575. I can add 825 to both sides. 300y equals 2,400. When we divide, we get y is 80. Then we need to find our scale factor and similarity ratio. So for the scale factor, we already have a side that has a number in each part of the triangle. So remember that the scale factor is new over old. So the first triangles are old, the second triangles are new. So we have 75 over 45, and that reduces to 5/3. Our similarity ratio is old over new, so we can just take the reciprocal. So our similarity ratio would be 3/5. Number 4, determine if the polygons are similar. If so, write a similarity statement and find the scale factor. So in this case, if two sets of angles are already congruent in the triangle, the third angle must also be congruent. So we know that A is congruent to F. We also need to show that the sides are proportional. So the sides that match up need to all reduce to the same fraction. So AB is touching the red marked angle and the angle with two arcs, which is similar to the side EF. So one proportion that we're going to set up right now is 14 over 7, and that reduces to 2 over 1. Then I'm going to look at another set of sides, so I'm going to do BC. B is touching the angle with two angle arcs, and C only has one angle arc, so that side is similar to ED. So we have 20 over 10, which reduces to 2 over 1. And our last set of sides, AC, corresponds with FD. So we have 28 over 14, which reduces to 2 over 1. So because all of the sides reduce to the same ratio, This means they are similar. So because they're similar, we're going to write a similarity statement. So we're going to name our first triangle. So I'm just going to name it ABC. We're going to use the tilde, which means similar. And then we're going to name the other triangle. Now, here is where we got to be careful naming the triangle. We got to look at which letters match up. So A matches up with F, B matches up with E, and C matches up with D. And the last thing we need to find is our scale factor, which is the new triangle over the old. So we have new and old. So when I set up my scale factor ratio with my new and my old, my new triangle has a side of 7. My old triangle has a side of 14. So my scale factor is 1/2. Number 5, ABCD and EFGH are rectangles. ABCD is similar to EFGH. What is the scale factor that dilates ABCD to EFGH? What is the length of DC? So first, I know in a rectangle that my opposite sides are congruent. So I'm going to label all the sides of our rectangle so it makes it easier to match up corresponding sides. So if I need to find the scale factor, I need two sides with numbers. So I know that AD is 12. AD is the first and the last letter, so it corresponds with EH. EH also has a number, so we can do our scale factor right away. So in this case, the scale factor is still the new over the old. So we have 9 over 12, which reduces to 3/4. The last thing we need to do then is find the length of DC. So in order to do that, we need to find what X is. So right now we know that we can use 12 over 9 because those sides correspond. And then we're trying to find DE or DC. And DC is the third and last letter, which correspond with GH. So 2x plus 1. So the other part of our proportion then would be 4x minus 8 over 2x plus 1. So I'm going to cross multiply. I get 12 times 2x plus 1 equals 9 times 4x minus 8. So when I distribute, 24x plus 12 equals 36x minus 72. I can subtract 24x from both sides, and I get 12x. I can also add 72 and get 84. So when I divide, x is 7. So if I need the length of DC, DC then is equal to 4 times 7 minus 8, which would get us 20. Number 6, determine which of the rectangles are similar. Show mathematical proof and justify your answer in complete sentences. So we need to come up with a way to set a ratio that's going to be the same for all of our rectangles. So in this case, I know that our rectangles, by looking at them all, have a shorter side and a longer side. So I'm going to compare by doing the shorter over the longer side and see what the ratio is reduced to figure out if any of them are similar. So in A, my shorter side is 6, my longer side is 10. This reduces to 3/5. In B, my shorter side is 12, my longer is 18, and this reduces to 2/3. C, my shorter side is 21, my longer side is 35, and when I reduce that, it becomes 3/5. C, or D, my shorter side is 24, my longest side is 40, and this reduces to 3/5. So if I look at my ratios, I notice that A, C, and D all reduce to the same thing, so those are going to be similar. So we would say that A, C, and D are similar because the sides are proportional.